Pop quiz. Which arrow shows electrons moving correctly during bond breaking? A or B? The answer is B. Curved arrows always show electron flow. They must start at electrons, like a bond or lone pair, and end where those electrons will reside. In this video, you'll learn the rules for electron-pushing arrows, the difference between heterolytic and homolytic cleavage, and how to show bond formation step by step, while avoiding the classic pitfalls. To begin, remember that a mechanism is simply the step-by-step story of electrons. Arrows always track electrons. Start where electrons are, end where they go on an atom or in a new bond. Next, think in terms of nucleophile versus electrophile. Nucleophiles donate electrons, while electrophiles accept them. That polarity guides where arrows should begin and end. In typical polar organic mechanisms, most bond breaks are heterolytic. In this process, both electrons from the bond go to one atom, often the more electronegative leaving group. The result is usually an anion and a carbocation, or at least a charged pair. Here's a common mistake to avoid. Never start an arrow at a positive charge or empty space. Arrows always come from actual electrons. Since there are no electrons there, arrows must always start at a bond or lone pair and land on an atom or the bonding region being formed. So far, we've covered the essentials. Arrows start at electrons, aim toward electron-poor sites, and in heterolytic cleavage, both electrons move to one atom. Curious how much you're remembering? Your personalized practice test, flashcard set, and study guide are all waiting for you. Just tap the link now and keep watching. Future you will thank you. Now, let's contrast that with homolytic cleavage. Here, the bond splits evenly so that each atom keeps one electron. We represent this with single-barbed arrows, called fishhooks, that show one electron motion and produce radicals. Moving on, when forming a bond in polar reactions, push a lone pair from the nucleophile to the electrophilic atom. The arrow should land in the bonding region, and it's important to keep charges and electron counts consistent. Similarly, radicals combine when two single electrons meet in the bonding region. This is shown with two fishhooks pointing to the same spot to build the bond. Finally, let's put the rules together in a worked example. First, push the oxygen lone pair of ethanol toward hydrogen, not from hydrogen to oxygen. At the same time, push the HCl bond electrons to chlorine. The result is a new OH bond and a chloride ion as the leaving group. Same rules, clean arrows. To recap, always start at lone pairs or bonds. Aim at electron-poor sites. Match the arrow type to whether two or one electron is moving, and conserve both charge and electrons at every step. Master these rules, and mechanisms read like a map. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.